Veldhuis from Swiss, Denmark, from Swiss, will be chairing the session with 4 talks. And when we are done with those, we will have this poster session and an apero drink outside. So the poster session involves voting for the best young scientist poster, which are the ones with the red labels. And there's also one that is number 14, which is not on the list, that is in the back here, which is also came late and is also a qualifying poster. So take this sheet from your materials that you got when you registered and fill it in with 2 of your choices and put it in the box outside. You can also do it tomorrow morning. Okay? So I'm not going to introduce Marie Perez, she's not here in person, but she's professor at Delft, and she'll be talking to us about rainfall, remotely about rainfall sensing, the next generation. Crowdsourcing, as many of you know, she has been working on this topic of rainfall sensing with the Citizen Science Initiative, many low-quality measurements. What does this mean? How does this help us to advance science and measurement of rain? I think we're ready.
Of course. And then, but let me first take you to... First of all, thank you very much, Peter, for giving me this opportunity to present this keynote in a broadcasted format. It's a real pity I'm unable to join you in Pontresina. I was looking forward to catching up with all of you and to hear about your recent work. Now, you may be wondering what these kids are so very focused on, and what I can assure you is that they are helping to sense the next rain, and how exactly that works, I will tell you later. So in this keynote, I promise to talk about opportunities of citizen observations for urban hydrometeorology. And specifically, I'll address the question what we can learn from those potentially ubiquitous data, but intrinsically noisy, of course. And then, but let me first take you to one of those urban rain events that happened a few years ago in Amsterdam. And so what you see here is the radar image as it is available in real time. So that is uncorrected with ground stations. And you can see kind of a smooth rainfall pattern zoomed in over the city center of Rotterdam. So this is the amount of rainfall that is not super interesting. It looks like order of magnitude 15-20 millimeters. But then this is what was happening in the streets of Amsterdam. So then you wonder what is explaining the difference between these two? At the same time, this was happening at the call center of the city center of Amsterdam. Hundreds and hundreds of reports coming in from citizens. So the question is, how do we believe here? Do we believe the radar? Do we believe the citizens, right? The citizen observations are noisy, but there seems to be something going on. Now, definitely there was something with the radar, because here we compare so the uncorrected real-time available radar image with the corrected image that becomes available later based on ground stations. And so you can see there's substantial differences in the amount of rainfall that was detected between the two. But still, the amount of rainfall over Amsterdam is not necessarily the amount we would expect to generate so much flooding in the streets. And so one of the things it may have to do is the scale of the rainfall. You may remember this study that was presented by Susanna at the previous version of the Urban Rain 2015. And we looked at the critical scales of rainfall for urban hydrology, and one of the conclusions from this study was that the temporal resolution of less than 5 minutes is actually needed to capture the rainfall variability that is critical for a lot of the urban hydrological systems. And especially for the smaller catchments, also a spatial scale of 1 kilometer can be insufficient. So that is below the scale of what most conventional radar products provide at the moment. So then, what are the options? Now, one of the things that seems interesting is the availability of data from citizen weather stations. So these are amateur scientists, weather enthusiasts, and or Father Day presents, so these are installed. A lot of them are installed in cities, actually, as you can see on this map over the Rotterdam-The Hague region. We found 760 of those stations, so an enormous amount of data that is available in this area. And one station every 13 kilometers is what it equates to, which is a much higher resolution than we get from the professional weather gauge networks. As you can see here for KNMI, for instance, this is one every 1,000 square kilometers or one every 100 if we talk about manual gauges measuring only 24-hour accumulated rainfall. So potentially a very interesting source of information. And the type of gauge you see on the upper right. So this is typically a cheaper type of rain gauge, of course, compared to the professional stations. It is also smaller. It has a much smaller bucket volume. And there can be all kinds of issues, of course, with the installation. So we started to look into the data quality of those stations. And here you see work that was done by one of our master students, Rinske Hutte. And here you see an example of a comparison between the operational weather station by KNMI versus the citizen weather stations within a radius of 8 kilometers. And you obviously see issues, right? First of all, a lot of the stations are underestimating the amount of rainfall. Then some of these stations are overestimating, which, as we found, was related to incorrect tipping bucket volumes. These can be set by the user. There's a default, but sometimes users choose to change this. And then another issue, you see these horizontal lines. There's a long horizontal line that is very obvious, of course, for one of the stations. And there's shorter instances of that in some of the other stations. And that is, there was rainfall, it looks like, at least, measured by the KNMI station. But it was not detected by the citizen gauges. And that, of course, is a particularly hard source of error to detect. And so what Rinske did in her study, with the help of Hidde Leijns of KNMI and Lotte de Vos, who I think is in the room with you there, and Mark Schleis here at Delft University, she developed two types of filters to detect this undetected rain by citizen gauges. One is based on is a filter based on citizen weather stations in the surroundings of a given station, and the other one is based on the overlying radar pixel. Now, there's both limitations and benefits to those two types of filters. First of all, of course, a station-based filter could be applied anywhere, even in areas where there's no radar available. But it also relies on the quality of the surrounding stations that need to be of a certain quality, and also the density of the network, of course. There need to be enough stations in the close neighborhood of a station in order to use such a filter. So now, how did these filters really perform? I can show you just a few examples of the results that she obtained. Here on the left, we see a graph that shows the fraction of undetected rainfall instances, time steps, out of the total number of time steps. That's the blue dashed line. And you can see that this percentage is of the order of, say, between 0.5 and 2.5%. But that is of the overall number of time steps, out of which, of course, most are zero values, which you see in light green. And then in darker green, you see the actual rainfall values. And so this was what the citizen weather station filter detected. The radar filter is somewhat similar, as you can see on the right. Here we compare the two filters, and we see they generally agree in the number of intervals that they detect over certain periods, but there's also disagreement sometimes. So the radar and the gauge don't always agree. You can also see here that the filters tend to do the citizen weather stations tend to do better in the summer period as compared to the winter period, which is partially explained by the fact that a lot of the undetected rain was associated with low intensity rainfall. That is clearly harder to detect by the gauges, or it may be a seasonal effect to do with the leaves, or that, of course, we are not certain because we don't have access to the stations. And then overall, about the performance of these filters, we also compared to a reference where we introduced artificial zeros. And there we found that about 80% of the introduced zeros was also detected by the filters. So we're not capturing everything here, but quite a large number of the errors, say. Okay, so now what if we're going to use this data? So we know kind of the limitations and the errors in the data set, but now what if we're going to use those to create interpolated rainfall maps over cities? Is this a promising direction to go? Now here you see an example for over the center of Rotterdam. where there's two networks. One of the network is what we call TU Delft stations because they're operated and maintained by the university. Those are in red. And then in green is the network of the weather amateur stations. And yellow are the centers of the radar pixels over this area. And so we use these data sets to create interpolated rainfall maps and compare this to the radar. And here I show you an example of one snapshot out of a rainfall event. So on the upper left, you see the radar image, which is kind of a bit of spatial structure in the rainfall event. And then you see the interpolated maps, upper right, based on the sparser network of what we call TU Delft stations. And then on the lower left, the denser, based on the denser network of amateur gauges. And then on the lower right, we see the two combined. And so the first impression when you look at these images, they don't even seem to be looking at the same rainfall instance. And there's quite a few issues here. If we really zoom in, like there is this very high intensity rainfall detected by the radar close to the center, which, when we look at the gauge maps, was not detected by nor the TU Delft gauge nor the citizen gauge that is close by. So this might be a radar artifact that we're looking at. And then there's also this cluster of amateur stations in the lower left of the area, which you can see in the lower left image. There's no less than six rainfall citizen gauges that see a lot of rainfall, while the radar is not really measuring a lot of rainfall in the overlying pixels. So again, and this is why I also included this image on the upper right, which I presume you're all familiar with, right? When we compare gauge to radar, there's just a lot of difference between the two. So it's hard to find a reference. So that again, how can we really assess the quality of citizen gauges is not such a straightforward question to answer. But one of the things that's definitely going to help is, of course, to increase the density of stations so that we can do better intercomparisons. And so this is another route that we're following. Here we're working with citizens to build their own rain gauges. And the idea is, of course, that these are very cheap, very robust, because they're based on an acoustic principle, so there's no moving tipping bucket, and nevertheless sensitive to maintenance. Eventually the idea would be that lots and lots of people can have such a gauge, which would of course contribute rainfall information. And then also we wanted this to be a citizen science workshop really. So we had people assemble the gauge, the components of the gauge, like the microcontroller, the Arduino was connected. They connected themselves to the sensor as well as to the solar panel. And then they put everything into this box that you see in the middle photo that they could install in their own gardens, for instance. So the citizens really liked the workshop. They told us they learned a lot from it. We also, of course, did a little bit of explanation on how radar rainfall processes work, how the gauge works, what is the interest of collecting more rainfall information in cities, etc. But we encountered lots of issues. We did, this is just some examples of the problems that we encountered. We did this experiment over the last summer, which was not the most exciting summers, of course, for rainfall experiments. But we did have a few rain events. So the issues that we encountered very quickly is that there was leakage into the box where that contained the microcontroller. Now you can imagine that is of course a problem. And then also this was a very warm summer, at least definitely for the Dutch conditions. So the hot glue that was used to glue the parts together started melting, which again created leakage. Batteries even deformed due to the heat. And then the idea was that this is a very simple version, of course, of a gauge. It needs to be low cost and everything. So users would use an SD card to read out the data and then upload it to the internet. And that also did not always work out. So the idea of having a self-assembly sensor helped a lot for the citizen science part. But to get good data out of the sensor, it may not be the best type of solution. So for the next generation of gauges, you see the example of the gauge that we're going to introduce in the next citizen workshops that we're going to organize in spring. And this is a much more robust type of sensor that is not going to be so sensitive to leakages, temperature changes, etc. But also has less of an opportunity, of course, for the citizens to build, put the pieces together. And yeah, so what I'm trying to do here, you can see this is not very easy, is to really mimic a raindrop in order to demonstrate the gauge. More than a challenge, more of a challenge than you imagine. All right, now let's look at some examples of applications of citizen observations in the Global South, which I think is a very important opportunity, actually, for citizen observations. A few weeks ago, I was in Kumasi in Ghana. And here you see one of the urban rivers in the city of Kumasi. And this is in the dry period. So you don't really, I'll spare you the details of what exactly is flowing here. But this river is very susceptible to flooding. And here is an example of what happened last summer in the rainy season in Kumasi. So huge floodings. And yeah, so rainfall information and flood early warning, you can imagine, is a very important issue for cities like Kumasi. And then, not so surprising, where this flooding comes from, because this is also an image of what the river looked like in the rainy period between rain events. So, of course, waste is a huge problem. And then, coming back to what sensors and citizen observations could contribute, one of the things we are planning to do here is to install very robust, low-cost water level sensors that could be used to detect accumulations like that before they start to create floods, so by following the rising water levels. And also we're working on automated plastic detectors, again a very low-cost, simple sensor that could be used to detect the accumulation of plastics. But then, of course, in addition to that, it would be very important to have good rainfall measurements, because in Ghana and many cities in the Global South, the density of the networks, the quality of the available rainfall information is even much less than what we have here in Europe, typically. So here's another example from Tanzania, where community mapping was applied to, in this case, to map the drainage system. So this is in collaboration with schools. So as part of their educational program, the kids are sent out with a smartphone app to collect information about the drains. So they record the type of drain, the profile, they record the diameter of the drain, and that is all collected in an open street format, OpenStreetMap format, so it can be made easily accessible for the users. And this is an example of the data quality control that is done for this type of data, which is relatively easy compared to rainfall data, of course, which is so intermittent and so much more variable. But so here they do a couple of checks on data completeness, connectivity of the drains, profile consistency. So that is all for the hydrological network. Then for the rainfall measurements, you may be familiar with this, the TAMO project, which is the Trans-African Hydrometeorological Observatory. And this is also a type of very robust rain gauge, or weather station actually, because it measures a lot more than rainfall. And this is being installed at schools, in many schools throughout Africa. And there too, this is made part of their educational program for the children. So we visited one of these schools, and then the children really learn about weather parameters, rainfall variability, why it is important to have this information. They help maintaining the weather station. So again, I think this is a very interesting way of really improving the rainfall information, which is not purely citizen science in the sense that the kids build the sensors themselves or really do the measurements themselves, but by being part of a program that measures weather, they do learn a lot more about weather and rainfall. And here's an example of what this weather station measures. And as you can see here, it is very compact. It has all the sensors integrated in this one compact unit, and it has no moving parts. Of course, that is essential for areas where there's loads of insects, being able to creep into all kinds of holes in the gauges. And also, there may be less maintenance than in some of our networks over in Europe. All right, so what I think is the real opportunities for citizen science is, first of all, knowledge development, I think is very important. Empowerment through that, so people and children know a lot more, understand a lot more about rainfall information, why it is important, how it can help them to become more resilient to, for instance, the urban floods. And bottom-up data collection, I think, is very important, especially in areas where we don't have very strong professional weather agencies, or not very strong government more in general, and especially the local governments that, of course, in the end are going to be in charge of dealing with the rainfall information and apply it, for instance, for flood prevention. So there, I think, citizen observations can really make a difference. But then there's huge challenges ahead when we look at the quality of the information to achieve, first of all, a very high density that will be needed to do all the quality checks, and with that, to improve the quality of the data that we get out of citizen observation networks. And then coming back to these kids, because what are they so focused on? Now, I can assure you that what they are doing is really sensing rain, and the way they do this is similar to what I was trying to do, is they built their own acoustic sensor, and then they drip rainfall on top of it, and you can see how they are really listening to the rainfall patterns here. And I think with that, we help to prepare a next generation of weather enthusiasts, some of whom I hope might be contributing to finding solutions for the challenges that we have, so that eventually we could develop networks for sensing rainfall in cities at every street corner. Thank you very much for your attention.
Good to see you all.
Good to see you, and you just got an applause for your talk, so maybe you can do it again.
I'm so jealous, missing all these interesting talks there.
So maybe there are some questions, but would you like to say something after to what you showed us?
Whether I would like to say something?
Yes.
No, thanks for listening, and the floor is open for questions.
Are there any questions?
I have one. So Peter Mikkelsen, hello.
Hi, Peter.
Hi, Paul. So we just had this morning some presentations about microwaves, which supposedly are out there and can be used, and they should just be mobilized. And I know perhaps you have some thoughts on whether all the technologies and ideas that you're presenting here is the right way to go, or whether microwave links is the right way to go, or some kind of a combination. Because I hear a lot of things that I am not an expert of, and I'm not sure what to prioritize. When I go back to my country and, for example, advise the foreign ministry about what to pursue in a developing countries context, what is the right path, or is it a combined path that we can do? Do you have some thoughts on that?
Did you understand all of that, Marie?
Not every. I heard it's about microwave links. Maybe someone closer to the microphone can repeat the essence of the question.
Okay, the question is maybe far but nobody else asked the question. So I just thought we talked a lot about microwave links, which is an unconventional data source, you could say. And you also speak of unconventional data sources that are not really that common, and it's at least new to think like this. I'm just wondering, the citizen science approach is very different from asking data from microwave links, but it's new and different. I'm just wondering if you have some thoughts on whether these are two completely conflicting paths, or whether there's a possibility.
Well, not conflicting, I would say. I mean, one can definitely strengthen the other. I think So what I've tried to convey is that, so for citizen science, I think there's a lot of opportunity, especially in cities, because there's lots of cities around, but then so for the more stable type of parameters, like mapping the drainage system, maybe even measuring temperature or air pollution, citizen science could be useful because it's less sensitive to variabilities. But rainfall being so intermittent and variable, both in space and time, I think it's very, very hard to get valuable data from citizen science. So there, I would say microwave links for now are much more promising than using citizens as rainfall sensors. Having said that, so one of the things we're working on is these very robust and low-cost sensors that citizens could install, but then the sensors themselves should be of pretty good quality and require very little maintenance and being as insensitive as possible to the location where they are, because all these things you can't control in a citizen science context, and then when you have a very high density, so you can really filter out the ones that are installed under a tree or whatever else may happen, or on a balcony, then you could use such sensors in the citizen science context. But for rainfall, I think out of all the parameters that are of interest for cities, it might be the most difficult one. Oh yeah, maybe in addition to that, so I think I gave these examples of Africa because there, when we have weather stations, we have radar, we have weather agencies that support all this equipment, even strong microwave link networks that the data can be retrieved from, then all that technology is available and is going to be much, much better than any citizen science project could ever achieve, I think. But then when there's nothing of that, right, when there's no weather agencies that have, they're there, but they don't have maybe the budgets to develop these dense rainfall networks that are needed for the urban scale, let alone have the investment power and the knowledge to run radars. Then, even if citizen science has all these limitations, it's at least something. Out of where there's nothing there, then there could be added value from citizen science. So it very much depends on the context, but basically when there's nothing there, citizen science okay, but as soon as there's something there, very quickly it's going to be better than what citizens could do. Does that make sense? Mm-hmm. Very much so, yeah, and so, but that is very important. Is to develop the teaching material for the various groups, like from the primary school upward. That helps the children and later the students to use and understand the information that comes out of weather stations and also the context that they fit into. Like we visited a primary school, and there the children knew that the station was measuring like weather. But then we asked, so what do you think the information is for? And then they felt kind of silent. So that is an important part of the teaching program, right? So they also understand, as you're saying, the context of flood prevention or climate change, signals, etc. But then it has a lot of added value, I think, to have these stations there, apart from the data that you get out of it. But yeah, to teach the children and the students, I think it's great to have equipment there, right? Because it really, they can see the data, they can see the changes, they can see the extremes and everything. And also there's a school-to-school program where schools exchange between, say, European or US schools and then schools in, say, in Africa where the weather patterns are so different. I think that is also very interesting for the children to see how monsoons, for instance, impact areas that are so different from our very mild climates here up north. Hi. You're asking, somehow I can't hear it very well, even though you're very, I can see you're very close. Must have to do with the direction of the microphone. Ah, right, that makes sense. Now the microphone's on the other end.
Okay. My question was, how did you promote the citizen science workshops in Amsterdam? How do you find people who attend these workshops?
Yeah, that's not obvious. So we've done these workshops both in, actually we did them previously in Amsterdam, and then this year in Rotterdam, and then within this same project also in Birmingham and Brussels. And it was very hard actually to find people. People have families, you know, they have all these obligations. So we ended up working with people who are somehow connected to the water authorities. So we use that channel, and it's not only these people, but their friends and family and yeah, people close by. And then also through schools. So there is a University of Applied Sciences in Rotterdam. So we had students from there. In Brussels, I think there was also community groups that they got interested to join the workshops. Birmingham, I'm not sure, but I think Suzanne is there. She can tell you.
Thank you very much. So, thanks again.
Enjoy the rest of the conference. Bye.
Yes.
This one in the pocket? Or?
Yes, and the other one put next to the next.
So we thought in the structure of the program, we tried to have the monitoring sessions in the morning, and then, as you saw, modeling today. And then at the end of the day, we thought to look into the nowcasting, forecasting context. And I think there's nobody more appropriate for that in Switzerland than Veldhuis, and in particular Urs to lead this. So he'll be leading you through the remainder of this afternoon.
Yeah, thank you, Peter. Welcome for this afternoon session. It's on the next generation of rainfall sensing, and you see very young faces here in the room. I'm not referring to myself, but Daniel and many other faces. So this is the next generation of rainfall sensing. And that's in every modern democracy. We have a separation of power here. I mean, you have a beamer, you have nice pictures, you have a microphone, you have a laptop, you have 12 rings, and I have a big bell here, so
Okay, thank you.
balance of power.
Okay, thank you.